Hello students, today's agenda is to check 5.9. We're going to learn how to solve system of equations by substitution, and you will be able to do 5.10. Today students will be able to solve systems of equations by substitution. And so, before we start, let me ask you, if you give me a $20 bill, can I say that that's exactly the same as having one $10 bill plus two $5 bills? So it doesn't matter if you have one $20 bill or one 10 and two 5s, you still have the same amount, right? So when I say that I have y equals, I don't know, let's say x plus 2, just an expression. This means that this y alone is the same as putting together a number, which is x, and we don't know what that number is, plus 2, okay? Or for that matter, it can be different ones, because remember that the value for this one changes. So again, same thing as if we have y equals x plus 2, the value of y is exactly the same as having x plus 2, okay? It's the same amount. That's what this equal means, that they are the same, okay? Having that in mind, let's look at what we have in here. We have 2x plus y equals 4, and we have y is equals to x plus 1. So this is like if I have my $20 bill, and this will be the change in its place, okay? So if I take this out of this equation, eliminate it, but then put this in its place right there, it will be exactly the same, because it's like it says that y, its value of y is exactly this. So if I take y out and put this in its place, it keeps that equation equal. Ha ha ha. Okay, so I'm removing the y and putting the same value in there and not changing anything. So I'm going to put the whole equation as I remove y and put that in its place. Okay, so it's going to be 2x plus, instead of y, I put the value of y in its place. So this would be y before, but now it's x plus 1, because that's what y is worth, equals 4. Everything stayed the same, right? The 2x, instead of y, I put its value, equals 4. After that, I'm going to combine like terms. So the first thing that I did was to substitute. And then I'm going to combine like terms. So I noticed that my 2x is the same as x, so that will be equals to 3x plus 1 equals 4. So all I did was to put these two together. And I start solving by canceling. So cancel by subtracting. And so 3x is equals to 4 minus 1 is 3. Finally, I'm going to cancel by dividing. Cancel by dividing. And so x is equals to 1. Now I have already my x value, which is 1. Now I'm going to figure out y. And the second step of the equation is just like in elimination. You choose one of the equations and substitute the solution, okay? The answer that we found for x, sometimes for y, okay? So I'm gonna choose, believe it or not, in this case, the easiest one is the second one. So I'm gonna choose y equals x plus 1, but the x, we are going to substitute the answer. So it's gonna be 1 plus 1, so y is equals to 2. Okay, so that's where my two lines will meet. We have done the checkup test before, so I think I want to do it one more time so that you remember this. And so the checkup test is just getting the two equations and replacing my x and my y in both of them. So x is 1, so I'm going to replace 2 times, instead of x is 1, plus y, which is 2, should be equals to 4. 2 times 1 is 2, plus 2 should be equal to 4, and 2 plus 2 is 4, which is equal to 4, so check. Now I choose the second equation, and it says y, but we know that the value of y is 2, is equals to x, but we know that the value of x is 1 plus 1. 2 should be equals to the addition of this, which is 1 plus 1, which is 2, and 2 is equal to 2, so check. Okay, again, this is just to make sure that your answer, where the two equations meet, is correct. Okay, and you should check with both equations, not only one. Okay, again, when one of the variables is all by itself, notice how in here the variable that was all by itself was y, so that's why we took out y and replaced its value instead of the y. But in here, the value that we have alone is x. So we're going to remove x out of here and place its value in there. Okay, so everything all stays the same, including the 3. And because we have a coefficient in here, we're going to place a parenthesis so that we can put the 2y minus 4 inside. So we're going to end up doing distributive property. Minus y equals 3. Okay, again, all I did was see how we have 3x minus y. 3x minus y equals 3. But instead of the x, we put the value of x in its place. Okay, so that was substitution. So we substituted the x by its value. The next step is distributive property. And so 3 times 2y is 6y. 3 times negative 4 is negative 12. Everything else stays the same. Then we're going to combine like terms. And so we have a 6y and a negative y. So 6y minus y is 5y. And everything else we just bring down. The minus 12 equals 3. Then we're going to cancel by adding 12. And so we have 5y is equals to 15. We cancel by dividing by 5. Cancel by dividing. And so y is equals to 3. We have y already. Now we need to find x. Again, the same step from elimination method. We choose one of the two equations. It doesn't matter which one you choose, but I prefer the one that is isolated already because that makes it easier. All I have to do is replace this variable because I found y, replace it by its value that we've just found, and start simplifying. So x is equals to 2 times 3 is 6 minus 4, and x is equals to 2. Okay, so this is the point where both equations meet. Again, you can do the checkup test if you want to. Especially on tests, you want to make sure that you're correct on the test, right? For the homework, you can just try it, and then if you see that you get most of them incorrect, then that's when you want to do the checkup test, even on assignments. Okay, let's do one more, and this is a little bit tricky, and I'll tell you why. Which one are we going to remove? Well, the y is by itself, so the y is the one that we're going to remove from here. And in its place, we're going to give the 10 and the 5s for the, take away the 20, put in its place the 10 and the 2 5s. That's kind of like the idea. And so everything else stays the same, including the signs. So it's x minus, I'm going to put a parenthesis and put, instead of the y, its value, equals 1. Now this is a tricky part. We're going to, well, that was substitute, right? Substitute the value of y by its value. The next step is distributive property, and this is where some people get confused. They think that this minus belongs to the x only. So distributive okay, and so we bring this x down, and negative times x is negative x. Negative times negative 1 is positive 1. Because negative times negative is positive, and you just bring down the 1. Equals 1. We combine like terms. Combine like terms. That's the next step. And when we have x minus x, we get 0x. So basically that cancels, and we end up with 1 equals 1. So guess what? We don't have a solution for xy because the x disappeared. So one little trick, and I've been telling you about no solution and infinite solution lines, the ones that don't meet and the ones that overlap each other. When we have 1 equals 1 or 8 equals 8 or any numbers but both numbers are the same, you're just going to say infinite solution. Okay, now if your answer, let's say that this was a negative, if your answer was negative 2 equals positive 2, then you're going to say no solution. And what this means is that for this one, your line will never meet because one is a negative 2 and the other one is a 2. And for this type, that means that the lines are overlap. They're going to be one on top of each other. Okay? Again, when your variables cancel and you end up with numbers only, if the numbers are the same sign, same number, infinite solution. Different signs or different numbers, no solution. So you can sometimes have 0 equals 8, for example. That will be no solution. Or they have the same number but different sign, no solution. Okay? But same sign and same number, infinite solutions, lines overlap. I guess I should just scratch this one and say that these are no solution and these are infinite solution. Okay? These two are infinite solution. These two are two examples of no solution because they are different. Okay? So I hope this was helpful. And I hope that now you can do 5.10, but if you have more questions, especially about this part, you can come and see me. Otherwise, you can just start working on 5.10.